Hello, everyone. Good morning, good evening, and good afternoon. I'm Shinichi Nakasuka from University of Tokyo. And at the beginning of the 2025, I would like to give you some opening remarks about a UNISEC-Global meeting. So I'd like to show this picture. So this is a picture which was taken just before the world first CANSAT launch, which was taken place in 1999. So everything started from this moment. And starting from the CANSAT and the CubeSat were being developed, and the new world utilizing a micro nano pico satellite occurs. So I think this moment is very, very important. That was the first CANSAT launch. And I was very young. It was 25 years ago myself here. Okay, so I'd like to wish you the great, successful, and also healthy 2025. And at the beginning of this 2025, I'd like to give you two messages. The first one is maybe, as you know, this is the UNICEF Global key concept. If you go faster, go alone. If you go farther, go together. So that is very, very important concept, which has been many times given by Kawashima-san. Okay, and in order to realize that, what is important? In Japan, we say that the Senri no michi mo ippo kara. In English, a journey of 1,000 miles begins with a single step. That is very, very important. So if you want to do something, please start from very, very beginning, even from a very small step. Please, start something. And the continuation is very important. If you continue something, maybe in future, you can realize something. So I'd like to ask you to start something within this year. So this is my message at the beginning of 2025. Okay, now I'd like to move on to my proposal of the nano-satellite IoT Constellation program by international collaboration. Okay, and so I'd like to show the first overview of this proposal, why I give this proposal, and the merit of IoT Constellation missions, and the example of IoT mission, and I'd like to show the first step study to this IoT program, joint study. And finally, I'd like to give you the indication how you can participate in this program. First, how about developing a nano-satellite constellation in the as a UNISEC-Global joint mission? So the UNISEC-Global has been developing very rapidly, and we have so many members. And in every month, UNISEC-Global virtual meeting, we have a very good discussion every time. But in order to continue this kind of the community into the future, in order to more activate this kind of the community, we need to do something together. That is very, very important. So for that objective, I'd like to show one, a nano-satellite constellation mission as a joint program. So we assume something like this. So we jointly design satellite bus and mission payload with online guidance. So this is a kind of the educational session by online. And we will develop several satellites, and each satellite will be developed by each country. So, idealistically, each country it's better to develop one satellite, but it may be very difficult. So if it is very difficult, we will jointly search for international funds. And all the satellites launched have the common mission payload to contribute to solving global problems or local problems for each country as a constellation. So this is the overview of my proposal. And then the next question is, what kind of mission would be suitable for common mission? So for that, objective, I'd like to propose IoT satellites, or in some other words, store and forward satellites. So this mission looks like this. If you put, maybe so you want to put several sensors on the ground. Maybe you want to distribute many sensors on the wide areas. And if there is no ground infrastructure of the communication, if you want to get the data from these sensors, you should go to the sensor site and get the data. So that the activity is sometimes very time consuming if the sensors are distributed over a large area, or it is very dangerous in the disaster timing. Okay, so if you put a small transmitter to this sensor, which can send the data, collect such kind of the data when it flies over that area. So this mission is called IoT, or store and hold. The important thing is like this. So maybe these sensors will be distributed in the, not in-house. It is maybe outside of the house. So there is no, power provision. So in order to make a very small power system like a solar cells and so on, the required power of the RF transmission should be as small as possible. Okay, so we have been, doing some research, and finally we could achieve 8 milliwatt very low power RF transmitter to the space. But of course, if we utilize such kind of the low power RF transmission, the data rate should be very small, like 300 bps or less. But even with that kind of the small bit rate, we can do some meaningful missions. So this kind of the technology have been developed all over the world, and in our laboratory as well. We developed this technology and demonstrated in space using 3 kilogram TRICOM-1R, which was launched in 2018. And 8 milliwatt, a very low power RF transmission to the space at the altitude of 1,000 kilometers was possible. And so I'd like to show the merit of IoT as a common mission in the UNISEC-Global community. IoT satellite can be developed in 3U or 6U size and does not require so high level a satellite bus. Okay, it is rather easy to develop such kind of the satellite. And as I said before, the data rate is very much limited. But even such kind of the limited data rate, like a 300, 500 bps, can send very important ground information. So the idea of the utilization is very, very important. And if you launch only one satellite, the communication service time is something like 14 minutes per day. It is rather small. And if the number of satellites increases, then the service time increases, of course. And if we, can make a launch orbit coordinate, if we can, coordinate launch orbit, that will further increase the service time. Okay, but it will be very difficult if we don't have much money for the rocket launch. And the ground sensors can be invented or improved even after the satellites are launched. So this is the most important part of the IoT. So satellite bus can maybe similar into the future, or some modification will be occurring into the future, but almost the same performance. But in that situation, ground sensors can be invented or improved. Okay, so you can develop new sensors suitable for problem solving in your countries, which will appeal to your government. So this activity is very important. So mainly this is because the government will be the main source of the funding for the space development activities. So you should appeal to your government that the space is very important to solve the social problems and so on. So this IoT mission, if you utilize this IoT mission, you can have opportunity to appeal to your government. And if for example, if one country develop a very useful sensors, these sensors can be shared between member countries. So the other country also can utilize that kind of the sensor. So maybe the good sensor will be distributed over to the world. So IoT mission has this kind of the merits. So, and how about satellite side? So this is what we developed in 2018. 3U CubeSat called TRICOM-1R. It is a 3U size, and the power is very low power, and the battery downlink capability and uplink capability was made by UHF. And the attitude control is very simple. We only utilize a B dot attitude, how can I say, rotational speed suppression control only. And the sensors is very simple, and the actuators are also very simple. And RW may not, maybe don't have to be implemented. Only the MTQ would be enough. Okay, and the camera and the sub camera was implemented in just trick one, but I don't think these are needed for the IoT missions. So this is something like additional sensors. Okay, and how about the communication payload? So in order to realize the 300 bps communication, so we implement this kind of the 8-channel transmitters, receivers in the satellite in parallel. And the transmission duration is like this, and the transmission power from ground is typically 20 milliwatt, but as I said before, 8 milliwatt is also possible. And the frequency band is a very important issue. So in Japan, in the 920 megahertz is a frequency where there is no license of usage is required if the power is less than 20 milliwatt. So we utilize this frequency, but this is a very important discussion items. Okay. And this one module can be a ground transmitter as well. And if we make a 3 by 3 centimeter module together with 10 centimeter by 10 centimeter antenna, and if we add some battery or other system, we can develop the very simple ground transmitter. It's very cheap and very simple ground transmitter would be possible. And as I said before, this satellite was launched in 2018 and staying in orbit about 8 months. And during at that time, we did a lot of experiment, not only sending the signal from Japan, but also sending signal from other countries. And based on that, result, we started a collaboration with Rwanda, African country, and we developed the one satellite called the RASAT-1, which was also the 3U CubeSat, and which was launched in 2019 to ISS and deployed from ISS. It stayed in space about 2 years, and we did a lot of experiment of IoT missions. And so this is an image of the collaboration of the, as to the IoT missions. So we invited many people, many young engineers from Rwanda, and we developed the satellite all together. And after the launch of the CubeSat, we collaboratively do the experiment like sending the signal from the ground, like a pH or moisture level sensors, blood or water level sensor, and so on. So this kind of activity is very, very good for the UNISEC-Global community. Okay, so then the next question is, why the constellation is required? What is the merit of the constellation as to the IoT missions? As I said before, only one satellite provide 4 times 10 minutes. So this is a SSO, synchronous orbit case, chance to receive data from ground, just 40 minutes per day. So that is not enough. And even if urgent data is sent to the satellite, some data relay occurs until the data is downlinked to ground. And if a satellite fails, no backup is provided. So constellation is very important. And the participant can use all the satellite for IoT data collection. That is very important. So we collaboratively develop the satellites, and the participant can use all the satellites for IoT data collection. That is very, very important concept. And using this communication system as a constellation, I think we, university community, may be able to contribute to the world by obtaining worldwide data. So that will be used to solve global warming, flood, desertification, and so on. So we'd like to have this kind of the vision into the future if we start the IoT mission collaboration. So how we start the study as to this, collaborative missions? I think the first step is to define of IoT mission details. Okay, so the first step is to design the various parameters for our target IoT system. And these parameters will be used to design the IoT transmitter and receiver. Transmitter will be on the ground side and receiver will be on the satellite side, and also the satellite bus as well. And how many satellites are needed. So these kind of the very important system parameters will be designed based on this kind of the parameters. So let me introduce some of them. So bit rate of transmission, as I said before, it is not very high level, like a several megabps. That is very impossible. So maybe the 300, 500 bps would be, how can I say, what kind of the, mission would be possible using such kind of the low bit rate. And the total amount of data per one transmission in byte and require the transmission power and input power to the transmitter. That is very important because, as I said before, these transmitter and sensors will be distributed in the outside, not in-house. So we need to reduce the transmission power as little as possible. And the interval of data reception from the sensor to one of the satellites, that is very important. And the allowable latency from data reception by satellites to the downlink to one of the ground station, and error rate in the data transmission. So of course, the 100% is very difficult to achieve. So we should allow a certain error. So, but if the error is very large, it is not good. So how is the tolerant level of the error rate? That is very important, parameters. And the decoding capability to correctly decode many packets which are coming to one satellite at the same time. So if the ground sensors are distributed in the vicinity, these sensors may send the data to the satellite all together at the same time. So the satellite side should decode this kind of the incoming data of the many data. Okay, so how correctly such kind of the data can be decoded. That is a very important parameters. And as I said before, the frequency for IoT data transmission. So we should search for the frequency regions which can be utilized for this mission, and we would like to find out the very good frequency region for this mission. Okay, so these parameters should be defined. Then we can design IoT transmitter and receiver systems and satellite bus system as well. Okay, but before designing these parameters, we need to find use cases for IoT missions. So many countries may have some use cases to utilize this IoT mission for your own problem solving and so on. For example, so some country want to monitor the behavior of the animals like elephant or like tigers and so on. So if we put the GPS positioning as sensors to these big animals and which can send the IoT data to the sky, then we can monitor the position of this animal every time. So this is one area of the application. Wildfire detection and monitoring, that is also very important. If we distributed many low-cost, temperature sensors, and maybe these, temperature sensors can detect the occurring of the wildfire, and if that information is sent to the satellite very quickly, that will be contributing to the mitigating the wildfires. And flood detection and monitoring. For example, if we put several very low cost, water level sensors. So please consider what kind of the water level sensor would be very, effective and low cost. Okay, and then the information is sent to the satellite. Then we can monitor the flood all over the very wide areas. Okay, and as to the agriculture field, maybe the pH of the soil or moisture level of the soil is very important information. And if we put such sensors on the ground, and that sensor, the information is sent to the satellite, then we can do something in order to make a healthy growing of the agriculture crops. Okay, so this is one example, for example, of the use cases of the IoT mission. So maybe you will think up some other type of the IoT mission in your countries. Also, as I said before, the important thing for our community is to, utilize the space for problem solving of the global problem on the earth, like global warming, wildfire, deforestation, desertification, flood and drought, and so on. And I think the situation seems to be getting worse. So how our sensor network using IoT system can contribute to solving this kind of the problem? That is a very, very important issue. Then maybe in future we can get something like a very favorable actions from the government, each country's government, or possibly in the United Nations and so on. So that is a future vision. Okay. So in the first step, I'd like to ask all of you to find the use cases, so use case study for IoT missions. So please consider what kind of the ground sensor systems are effective in addressing your country's social or environmental problems. Okay, so if you think of some, such kind of the, IoT application, please consider how frequently should the sensor get the data and send it to satellites? Once per day, at a 2-hour interval, 30-minute interval, and so on. Secondly, how much data must be sent to the satellite in one data transmission? For example, if one data includes 8 data items, each of 1 byte, then the packet size is 8 bytes. So 8-byte data should be sent to the satellite. Thirdly, how much delay is allowed from the time when the satellite receives the data from ground to the time when its data is downlinked to the ground station. Okay? For example, if the data to be obtained is urgent data, then the allowed time may be 1 or 2 hours. But if it is agriculture-related information, 1 day or 2 days delay may be allowed. Okay? So number 3 is like that. And number 4, how many sensors will be placed in the vicinity of one another? For example, within the 10 by 10 kilometer area, how many sensors do you want to put? Okay, in order to make your IoT mission meaningful. So if you come up with one idea for IoT mission, please study more about the required sensor and the mission's impact on your society. Please specify what kind of the sensor will be used in your IoT mission, who will use this data for what objective, and the mission's contribution to society. Okay, so this is the first step study. So every time, in order to develop a satellite, we should first define the missions, meaningful missions. And then, based on that mission, we would like to go into the detailed conceptual design of the satellite, and then go into the detailed design of the satellite. So every time, the mission definition, mission study is very, very important. So this is what I want you to do as a first step. How you can participate in this program? Please show your intention by sending email to the UNISEC-Global at this address, and download or receive from the Secretariat the file to explain the IoT program in more detail, as indicated by the Secretariat. And thirdly, study possibility of IoT mission in your country, as I said before, by thinking first by yourself, and then by discussing with your colleagues in your organization. Or sometimes I'd like to recommend you to ask your governmental officers what is your country's social problems, and submit Excel files to describe your IoT mission idea to the secretary. So as many as possible. Okay, so this is what I want you to do in order to participate in this program. And let me show the several example of the Excel file to be submitted. So the section 1 is a mission overview. What kind of the sensor data should be sent to satellite? So the blue part is just an example, flood detection and monitoring. Okay, what kind of the sensor is to be used for your IoT mission? So in the flood detection and monitoring case, we need a water level sensor. Who will use the data, local or central governments? For what objective? To mitigate disaster and save lives. Okay, and the contribution to the society. So, for example, if your country has suffered from flood many times, and which will be mitigated by finding the flood quickly in wide areas. The section 2 is the requirements for the IoT system. How frequently should the data be sent to satellite? So for the flood case, just an example, once per 2 hours. Okay, how much size of the data is to be sent to the satellite? For example, one sensor requires 2 byte of data. Okay, position and depth of the water like that. So 2 byte data. And several sensors data will be sent to a key common station from which collected data will be sent to satellite. Then the total data amount will be 2 bytes times, for example, the sensor will be 50, then the 100 bytes. So there is two options. The 2 byte data will be sent from each sensor position, or it will be collected to a central station, which will transfer all together all the data to the satellite. Number 3, how much delay is allowed? The data had better be downlinked to the ground in 1 hour after reception. And how many sensors will be put in 10 by 10 kilometer? For example, along the dangerous river area with 2 kilometer separation and so on. And as to the priority, if you propose several IoT missions, please make a priority among these proposal. This is 5 is highest and 1 is lowest. Okay, so the first step, I'd like to get as many this kind of the IoT missions as possible from you, which can solve your social problem in your countries or global warming or other global problems as well. And then based on that information, I'd like to go into the next step. Okay, so this is what I want to say now. Thank you very much.